Today we're going to talk about the integrals of the form e to the u. So we've done the derivatives of e to the x, now we're going to do integrals involving e to the x. The rule, super simple. It's just the reverse of the derivative rule. So the integral of e to the u du is e to the u plus c. So you're going to be using u substitution pretty exclusively with these. And here's kind of how you know what to choose for u. If there's just one e, if there's just one e in the integral, then u is going to be the exponent. Now, if you have more than one e function, and we saw some of these with the derivatives, in that case you need to use just kind of your normal u rules. You need to choose something that's inside of a power, a radical, a trig function, or a denominator. And we'll do examples with both so you see what I'm talking about. But if you can just keep this in mind, if there's one e, then u is going to be the exponent. If there's more than one e, then you're going to use the normal u rules. So first example, e to the 3x plus 1. This is an example where we just have one e. So I'm going to choose my u as my exponent, 3x plus 1. Again, 1e, u will be the exponent. The derivative of that is 3dx. Well, I don't have a 3, so I have to divide it over. And that gives me 1/3 times the integral of e to the u du. Like I said, easiest rule there is, e to the u du just becomes e to the u plus c. So that's 1/3 e to the 3x plus 1 plus c. That's simple. Okay, next example, we have 5x e to the negative x squared. Again, there's just one e in this problem, so I'm going to pick u as the exponent, negative x squared. The derivative of that is negative 2x dx. Okay, now this one's a little fuzzier because we have a negative 2 and we want to change it to a 5. So I would start, we don't need the negative 2, so divide both sides by negative 2. That gives us negative 1/2 du equals x dx. We do need a 5, however, so to multiply both sides by 5, and now it matches. You may be able to see right off that negative 5/2 would have done that for us, and if so, that's great. But if it's not easy for you to figure out that fraction, then just do it in 2 steps like I did here. So now we get negative 5/2 integral of e to the u du. And the integral of e to the u du is simply e to the u plus c. So the only thing we have left to do is plug in negative x squared back in for u. You can always check your answer by taking the derivative and seeing if it matches what you originally had. Alright, next example. Still just one e, so we're going to continue to choose our u as the exponent. Alright, if it helps, you can rewrite this 1 over x as x to the negative 1. Now remember, we're taking the derivative here, so the derivative we multiply by the exponent and subtract 1 from the exponent. So I'm going to rewrite that as negative 1 over x squared dx. Okay, well if you look over here, we actually do have 1 over x squared, because we could rewrite this way. So this is a good match. We just have to move the negative sign over, so multiply both sides by negative 1, and we'll end up with negative e to the u du. Rule for negative, or e to the u du is just e to the u plus c. So our final answer is negative e to the 1 over x plus c. Okay, moving right along. We have sine of x e to the cosine x. Still just one e, so I still use my u as the the exponent. The derivative of cosine is negative sine x, which matches what I have except for the negative sign, so multiply both sides by negative 1, and I get negative integral e to the u du. The rule for that, super simple, e to the u plus c, so we get negative e to the cosine of x plus c. Alright, now I believe we're moving into the ones with more than one e. Yes. So if you look at this problem, this is the first one where e shows up twice in the same integral. So this is the time where we don't pick the exponent. We just think of the normal U rules. And the normal U rules say that we should pick something inside of a power, a radical, a trig function, or denominator. So in this case, we would want to pick what's in the denominator. U would be 1 plus e to the x. Take the derivative. Derivative of 1 is 0. Derivative of e to the x is e to the x. So if you notice, that's a perfect match for what's on top of our fraction. So we end up with du over u. And you should recognize that rule. The integral of du over u is the natural log of the absolute value of u plus c. So we get the natural log of the absolute value of 1 plus e to the x plus c. Alright, now we're ready for the last example. Last example, e to the x times secant squared of e to the x. So if it helps you, there's understood parentheses right here. This e to the x is inside the secant squared. Again, there's more than one e to the x here, so that means we need to use the normal rules for picking u. We need to look for something inside of a power, inside of a radical, inside of a trig function, which is what we're going for here. So u would just be e to the x. And the derivative of u is also e to the x. Okay, well I just want to make sure this is clear. This is going in for this. That's where our u will go. This is going to replace the e to the x on the front and this dx. So we'll actually end up with secant squared of u du. The antiderivative of secant squared is tangent of u plus c. So our final answer is tangent of e to the x plus c. Alright, so hopefully that helps you. Remember to use u substitution. If there's just one e, use u as the exponent. If there's more than one e, use the normal rules. To practice this, go to page 349 and do number 87 through 107 odd.